Hi everyone, it's Kat here, and welcome back for a third episode of the Poke and Prod tutorial series. In the last episode, we created a player and implemented a lot of its functionality from scratch. We did movement, attacking, and animation. In this episode, we're going to do those same things for the enemy. So let's get into it. If you remember from the first episode, the enemy were these green ghosts that exploded on impact with the player. We're going to break up that functionality into a couple sections. We're going to implement a trick to act like a line of sight, a way to keep track of the player so that an enemy can follow it, and a way to handle despawning the ghost and spawning the explosion prefab. Before we make the ghost, I kind of want to do something I forgot to include in the last video. We're going to make the player into a prefab. So what you're going to do is you're going to go to your assets folder and you're going to click on the prefabs folder. Then you're going to drag the player object and drop it. This allows us to easily produce other instances of the player if we ever need to use it. For instance, you can just drag and drop the player onto the blank game object. Or you can drag and drop it straight onto the scene to choose its location. Those prefabs might not be completely necessary in this game, but it's important in many other cases and good to get into the habit of doing it. So now, let's move on to actually making the ghost. We're going to do almost the exact same thing we did with the player. We're going to right-click on the hierarchy and go to 2D Objects Sprite. We're going to name it Enemy. So reset position, go to sprite, and type in version1_walk00. This is the ghost that we're going to use. Let's drag this a little bit over here so we can see it better. Okay, next we're going to add some components so we can do some physics stuff. First, we're going to add a circle collider, 2D, and we're going to do rigid body 2D. So this is a massive hitbox. Let's change it so it makes a little more sense. I have some saved values for offset. The X offset is going to be 0, Y is going to be 0.09, and radius is going to be 0.61. It's a little big, but it should be okay. As for rigid body 2D, let's see if I can deactivate the gravity scale by setting it to 0. And we're going to freeze the rotation by freezing it, or by freezing the Z component. Before we move on, let's do something pretty important. We're going to go up to tag, which is what we talked about in the last video, and set it to enemy. This way, when we try to do attacks and checking if hitboxes work, it checks the tag of enemy, and hopefully it accesses the correct one. Now, we're going to do something different. The way we have it in the completed project is if the player gets within a certain radius of the ghost, then the ghost locks on and starts following it around. How we're going to do that is we're going to use a trigger collider, but since we already have a collider on this one, it's a little funky if you add another collider on top of this. So we're going to make it a child object of the enemy. So you're going to select enemy, you're going to right click on top of it, and make a 2D object. Alright, you're going to create empty, and let's name this line of sight. So we're going to go to add component, and we're going to create another circle collider. And we're going to add a rigid body 2D to it. Down to rigid body 2D, we're going to deactivate the gravity scale and freeze the rotation. So one thing is going to be different about the circle collider, in that we're going to click this thing right here, which is trigger. When you select trigger, if you haven't been over the collider lab before, it makes it so that there is no physical impact, in that if you run into this collider, nothing would physically happen. However, it sends a message to something that we will have to later code that causes some function to happen, and we'll go over that in more detail once we write the code. But just remember for now, it's set to trigger. The radius we're gonna make a little bigger. this is going to be the radius that we want the ghost to be able to find component. So I have it set to 4, which is pretty decently sized. Alright, now that this child is created, we're going to go to scripts, and we're going to right click and create a C# script for an enemy, but we're going to call this enemy. Double click and open it up. Just as before, we're going to remove this stuff and we're going to create some regions. So again, we need some movement variables. We have some unity functions, and we have some movement functions. So going to movement variables, we need public float move speed. Does this look familiar yet? One difference is that we actually don't need to handle input because we're not actually going to be controlling the enemy. The enemy just needs to know exactly where the player is, and then we can use some math to figure out which direction it needs to be moving. Okay, so down to unity functions, we're going to have a private void awake. This, if you remember, runs once on creation. And then we're gonna have runs every frame. This is going to be private void update. So now to show you what the regions are for. So if you notice, this is all one region. If your code gets really cluttered, if you hover this on the other side, you'll see these little dashes and boxes. If you click that, it collapses into this nice little Unity Functions tab. You can do that for all regions, and then if you need them, you can just click on them again. It's really handy if you have massive code files and you really need to organize stuff. One last thing, we need the physics component itself. So region physics components, and we need to get the rigid body 2Ds. So type rigid body 2D, and then we're gonna call this enemy RB. And then if you guys remember how to get it, it's enemy RB equals get component type rigid body 2D, and then with a call at the end. Alright, and so we need one more thing, and that's an access to the player itself. So region, and I'm gonna call this targeting variables. We're going to name it transform. The transform has a couple of values it holds: the position, the rotation, the scale, the name, and a bunch of other things. But we're mainly concerned about the position. We're gonna call this player. We're gonna make this player public because somehow we have to set it and we have to find the player, and you'll see how to do this in just a second. We're not going to find player in awake because we don't want the ghost to immediately know where the player is. In fact, we're going to have something else entirely access this variable and set it for us. So let's go do that right now. The reason we made this line of sight child object was for that reason. Essentially, if something enters this collider area within the green circle, the enemy we're going to have a script on line of sight that tells the enemy script where the player is, or exactly who the player is. And then from there, the ghosts are gonna move towards it. So let's make the script for the line of sight. Go to scripts, and we're going to create a C# script. Call it line of sight and open that up. And this one's gonna be really short. It's gonna have one function, so we're gonna delete these as usual, and we're gonna type private void on trigger. you're gonna see that there's 6. Ignore onParticle trigger. We're just gonna talk about the 6 ones above. So onTriggerExit, onTriggerExit2D, onStay2D, and stuff. So if you remember, we add Collider2D to line of sight, right? This is trigger. Whenever something that has a collider enters the area, we're going to call this trigger here, on Collider2D. So we want to figure out if whatever enters here is this value. So I'm going to rename this to col. This function is called when something enters the trigger collider. So what we want to do is check if the thing that entered is the player, and then move on from there. So let's do that. Let's check if we call the player, and we do that by checking the tags again. So if call.compareTag is player, the way we check what tag we're comparing is we go to check where the player is, and then here's the tag player. Make sure you use capital letters on the P, or it won't work. So if this returns true, we want to somehow access our enemy script here, then our line of sight. So the way we do that is this nifty function called getComponentInParent. So you'll scroll down here and see. So since line of sight is a child of enemy, this function can access a lot of the values or a lot of the components in enemy through this call. So we're going to pass in the type. And the type is going to be the script that we want. So the type is enemy. You'll see that the class enemy shows up here. It's a function call, so make sure you use parentheses.player because that is the public transform that we want to set. And we're going to set it to call.transform. To make sure we're going to print this out, log if we've seen the player, run at player. So we can go back and check if we run into the collider. Then it should print this. So let's actually do that now. Let's make sure the player starts outside of the colliders, that way we can move into them in a second. In order to test this out, we have to do a couple things first. First of all, I'm going to drag the player outside the radius. I'm going to add the line of sight script to the line of sight object. So you can just drag it and either drop it on top of here, or you can just drag it on top of the component. And now we're gonna do the same thing for the enemy. So enemy script and just drag it onto there. You can notice that the player is currently none. We'll see this change as soon as it enters the line of sight. I'm going to press play and this should work. So it printed exactly what we wanted. And if we check enemy, let's see if it set it. So now it has access to the player itself. Now we can move on to actually making it move towards the player once it reaches the line of sight. So the first thing we're gonna do in update is check if we actually can see the player. So check to see if we know where the player is. We do that. We check if this is null. And if it is null, we're going to return because we don't know where the player is. And then if it's not, if this is not the case, then we just have to know where the player is, which means we can just call our move function that we are about to write. Private void move. This is going to move directly at the player. An easy way to do this is to take player position and then enemy position and subtract them. This would give you direction or the opposite direction if you subtract the wrong way in which to move. So we're just going to calculate the movement vector. And the math is the player position minus the enemy position equals direction, player relative to enemy. So we can take advantage of this by saying vector2 direction is equal to player.position because transform has position variables, minus our current transform is transform.position, and now all we have to do is create. Set our velocity. So enemy rigid body dot velocity equals direction times move speed. This might seem fine, but there is one slight issue. Initially, the further these two are apart, the larger this vector 2 will be, which means the faster the bat will move. This doesn't seem like a mechanic that we want, so what we want to do is to normalize it. Normalizing is just a math trick to make sure that the magnitude of this vector is 1. You'll remember that we didn't actually have to do this for player. The reason is because we used all unit vectors. So your unit, vector 2 up, left, right, down, they're all magnitude 1 already. So you don't need to normalize them. Okay, back to the player. So we've done a check to see if we know where the player is. And if we do know where the player, we calculate the movement vector, and then we set the velocity. Let's go see if this works. And first, we are going to set the move speed to something that is not 0. Use a move speed of 2, so it is slightly less than the player, which makes it a bit easier. So if you move, the player starts. The enemy starts moving towards you, follows you around. But if you run into each other, it kind of just pushes you. It looks kind of funny doing that. Next, we're going to work on how to create the explosion itself. So first you'll notice that the explosion is a prefab already. We left it here for you. If you drag it into the scene, if you press start, it should just start, casting the animation over and over. So we actually created a script for the explosion prefab, which should handle the exploding and handling itself. You can look at it after if you want to, but it's only one line, so don't worry too much about it. Okay, back to the enemy and how to create the explosion. First thing we're gonna do is create another region. This one's gonna do attack variables. It's gonna be very similar to the other one, except a lot easier. Okay, so for this one, we'll only need 3 things. First one is going to be a float for how much damage it does. So float explosion damage. And we're gonna need another one for explosion radius. Lastly, we're going to need the actual game object, explosion prefab. This is where we're going to be storing the prefab so that we can bond the prefab whenever we collide with the player. Now let's move into our attack function. Alright, so this is going to be very similar to the player one, in that we are going to raycast very similarly. So private void explode, and this function just raycasts box for player and causes damage. It also spawns the explosion prefab. Alright, so the first thing we're going to do is that we're going to do the raycast stuff. So this is going to be almost identical to the player one. So raycast hit 2D, we're going to make an array of these types of objects. We're going to call it hits, equal physics.2D. This is slightly different, so we're going to use a circle cast instead, because explosions are circular. We're going to do something different in that we're only going to use the first one, because we don't really need much else. So we're going to use the origin, which is transform.position. We need the radius, which is explosion radius. And then the direction is going to be vector 2.0. It raycasts a little circle around where it was exploded. And then for each type is raycast hit 2D. So scroll to that. And so that is going to be titled hit. And we're iterating through these hits. If we hit the player, so if hit.transform.player tag is the player, we will want to create some damage. We're just going to leave this here because we're going to come back to it when we do health and damage much later. But we're going to debug log hit player with explosion. This is going to be something new. So when you create a prefab, or when you want to spawn a prefab in the game with your scripts, the function we're going to use is instantiate. So we're going to use spawn explosion prefab in the game. So the function call is instantiate, and then let's see if we can find it. So this first one just spawns the clone of itself, and you can also pass in other parameters. If you want to, I think this is the one we want. Okay, so the first is the type and the actual object you want to spawn, and that is going to be our explosion object that we pass in later. The last variable is rotation, which is fine because we don't really care about rotation. But we're going to pass in our current rotation. And the last thing we have to do is deactivate the object. So the way we do that is destroy this .gameObject. Okay, so now if for some reason explode is called, then it will raycast for each object in the raycast in order if it was damaged, and destroy this object. Actually, slight change. This should be outside the for loop. So now we have to figure out what calls explode. So how we're going to do that is similar to the onTrigger enter for what we had for the line of sight. There is a method called onColliderCollision, collision enter 2D. Difference between onCollision enter 2D and onTrigger is the type of collider it takes. You guys will talk about this more in the colliders lab, but quick rundown. Collision happens if you have a physical collider. So on the enemy, there is a physical collider. A trigger collider will mean you have to use on trigger. So just remember that. It's a small detail, but really important to remember. So we want to make sure that we're colliding with the player object. So we want to check if it hits player. So if call.transform compare tag, just as we did before, then we want to call explode. Call that there. Before we test this out in-game, let's go to enemy. We have to set a few parameters before we can try anything. So scroll down to enemy script, and the move speed we already set. Player is going to be set in-game. Explosion damage I think I have as 3 as my value, and exploded radius is 1. So the way we set this object is we're going to go to prefabs. We're going to click and drag this explosion prefab and drag it right over this line. Drop it in. Let's check it out. We can walk back and forth, and if enter on hit with the enemy, then it explodes. If you notice over here, it typed see player run at player, which means it saw me, and then hit player with explosion, which means that it was deleted. So everything is working now so far. The last thing we're gonna do in this episode is go to the animator for the enemy. So first thing we're gonna do is we're gonna go to the animations folder. We're going to make an animator controller and title it enemy. Let's open it up. This one is drastically simpler. We don't even need to do anything because our ghost floating animation works if it's in place or if it's moving. So it's actually just fine to create a state empty. We don't need to do a blend tree because there isn't actually multiple directions. We're going to call this flying, and we're just gonna select a motion. Click on the circle, go to enemy move, and that should be it. Now, we're going to go to enemy. We're going to try to drag this enemy. Make sure you drag enemy and knock enemy controller. Make sure that it has enemy as its controller. Save it, and then see if it actually works. So, as soon as the game starts, it should just float. Now, if you move closer, the ghost is still floating regardless of whatever direction it's facing. So now, if I run into it, it explodes, just like last time. If you paid attention in this area, you saw that it spawned an explosion object that showed up in this scene, and then despawned it on itself. Alright, that is it for this video. Thank you all for tuning in. And next time, we will be focusing on how to take damage.